Known as Bennu, the diamond-shaped asteroid hurtling through space in a near-Earth trajectory is colossal enough to extinguish life on our planet. But it's not alone. A NASA probe, OSIRIS-Rex, has been chasing the massive space rock for years. Now it's caught up with the body and is preparing to land on its surface. But the high-risk maneuver demands absolute precision. Approximately 66 million years ago, a large asteroid slammed into Earth near Mexico's Yucatan Peninsula. That triggered a cataclysm, an extinction event that led to the loss of 3/4 of the planet's biodiversity, including the dinosaurs. In fact, the impact transformed the environment into one that allowed Homo sapiens to evolve and flourish. A similar asteroid collision today, however, would mean the end of human civilization as we know it. Scientists have known about the risk of such an asteroid collision for decades. Indeed, the chances of it happening are 100% certain. It's merely a question of when. Hollywood, in fact, has already imagined the asteroid apocalypse with several movies. The 1998 box office smash Armageddon among them. But where Armageddon is a light sci-fi adventure starring Bruce Willis and Ben Affleck, the threat of Bennu is real. It's thought that asteroids were forged in the same high-energy crucible that gave birth to our solar system. These rocky bodies range in size from small pebbles to enormous hunks of stone measuring hundreds of miles across. Along with the sun, planets, and moons, their creation came about approximately 4.6 billion years ago when an enormous molecular cloud containing dust and gas collapsed in on itself. As such, small pieces of asteroids and other space rocks occasionally fall to Earth. Although most burn up in the atmosphere as shooting stars, occasionally, around 10 times a year, a small piece known as a meteorite makes it to the surface. As a result, meteorites often leave a small impact crater. Unless you have the cosmic misfortune of being hit by one, however, they pose no serious threat to human life. An asteroid the size of Bennu is another matter, however. The impact of such a large space rock would unleash kinetic energy equivalent to tens of thousands of atomic bombs. The shock waves would cause earthquakes and tsunamis, and the dust cloud would probably cool the planet for hundreds of years, devastating its ecology. Thousands of space rocks travel close to the Earth. By close, scientists mean around 120 million miles out. Most of them, though, are concentrated in the area between Jupiter and Mars. Bennu is one of 200 known asteroids with a solar orbit much like our Earth's. However, in fact, one Bennu year is equivalent to 436 Earth days, and the body passes perilously close to our planet on a regular basis, once every half-dozen years. Scientists originally gave the asteroid the rather catchy name 1999 RQ-36. Bennu's new moniker, however, was selected by Mike Puccio in a contest in 2013. The 9-year-old thought that the OSIRIS-Rex TAG-SAM sampling device and solar panels looked like the neck and wings of the Egyptian deity Bennu, who is often represented in the form of a heron. At 1,650 feet wide, Bennu is a comparatively big asteroid. Of course, the larger the asteroid, the easier it is to land a probe on it. Smaller space rocks, 650 feet across or less, tend to spin rapidly, making them unsuitable for landing on. With technological improvements, however, we may be able to explore a wider range of asteroids in the future. OSIRIS-Rex, an acronym for Origins Spectral Interpretation Resource Identification Security Regolith Explorer, is a $800 million space probe. With the help of its sensitive detection instruments and cutting-edge robotics, NASA scientists hope to extract 2 ounces of rock from the surface of Bennu and bring it back home. The main advantage of returning the sample is that a far wider range of tests can be carried out on Earth than in space. While OSIRIS-Rex boasts sophisticated technology, the most advanced scientific analysis require large, bulky equipment that cannot fit on a probe. Of course, flying the sample home makes the mission riskier and more complicated. In fact, the operation follows on from NASA's Dawn mission to the asteroid known as Vesta. However, if OSIRIS-Rex is successful, it won't be the first time a spacecraft has delivered an asteroid sample to Earth. Japan earned that accolade in 2010 with their Hayabusa spacecraft, and its successor, Hayabusa 2, is currently en route to the Ryuga asteroid. OSIRIS-Rex is part of NASA's New Frontiers program, which uses smaller spacecraft to explore our local solar system. Other participants have included New Horizons, which in 2015 completed a flyby of Pluto and Juno, which has been orbiting Jupiter since 2016. The proposal for OSIRIS-Rex was selected from a range of finalists in 2011. The probe has 5 specific instruments for surveying and analyzing the surface of Bennu. First, its visible and infrared spectrometer, OSIRIS, will be used for detecting organic chemicals and minerals by measuring light, both near infrared and visible. OSIRIS in fact identifies material properties by detecting the light frequencies absorbed by their molecular structure. Secondly, the probe's thermal emission spectrometer will measure the rock's temperature. Like the OSIRIS, it will also locate concentrations of chemicals and minerals. Together, these 2 instruments will enable NASA scientists to map the surface of Bennu and choose the most interesting site to extract samples from. The third array of instruments is a high-resolution camera suite composed of 3 units, including the Polycam, which will gather initial images of the asteroid, as well as potential sample sites. The MapCam will then scour the rock for satellites and stitch together topographic maps. Finally, SAMCAM will film the extraction of the sample. Next, the OSIRIS-Rex laser altimeter, OLA, will conduct a detailed scan of Bennu's surface. The data it collects and relays back to Earth will be used to create extremely detailed models of the asteroid in 3D. Similar technology was recently used to reveal the location of Mayan pyramids in the jungle. Finally, the probe's regolith X-ray imaging spectrometer, REXIS, will detect the X-rays coming from the asteroid. Those results will contribute data to a map of the rock's elemental properties. Specifically, the information gathered by the REXIS will reveal the atomic structure of the asteroid. Just as the fossil records contained in the strata of the Earth underpins our knowledge of geological time, so the asteroids in our solar system are vital to our understanding of cosmic time. Scientists hope that by studying material created at the dawn of the Sun, we will gain new insights into planetary formation. But NASA is also interested in the theory that biological life did not begin in Earth's primordial ocean. Rather, it migrated to our planet on an asteroid. Bennu, in fact, appears to have particularly high level of carbon-based components, and further analysis of its composition may yet provide new insights on the origins of life. In addition, there's the asteroid's monetary worth. The mission will develop important technologies for space exploration that will benefit anyone interested in exploring or mining asteroids. Dante Loretta, OSIRIS-Rex's principal investigator, explained on a space agency press statement in 2013. Whether it's NASA's or a private company, he went on. Given the recent growth of private investment in the space sector, an industry now led by billionaire entrepreneurs as much as national space agencies, it's not hard to imagine a future where asteroids are regularly mined for fuel or metallurgical resources. It may, in fact, one day be cheaper to mine asteroids in space than to mine the Earth. Above all, though, the data gleaned from the mission will enable scientists to better predict the trajectory of asteroids and presumably influence their course. One possible application of such knowledge could be terraforming. In 2017, for example, scientists from the Lake Matthew team proposed a scheme called the Mars Terraformer Transfer. Believe it or not, the plan involved crashing an asteroid into another planet. The scientists say that such a collision would cause the Martian bedrock to heat up and release its frozen groundwater. This in turn would create a lake lasting for millennia. The water from the new lake could then be used to supply a city-sized colony, effectively sidestepping the big technical challenges of terraforming an entire planet. Moreover, understanding the orbit of asteroids such as Bennu is necessary for averting collisions with Earth. In Armageddon, it took a plucky band of oil rig workers to drill a hole in the rogue space rock, plant a nuclear device inside, and blow it to pieces. In the future, probes such as OSIRIS-Rex may be able to carry out such an operation more precisely. OSIRIS-Rex launched in September 2016. Its first maneuver involved setting up for a gravity assist. Then, just over a year after leaving, the probe arrived in position for the second maneuver. This involved a brief glimpse of Earth during a flyby intended to add speed for the onward voyage to Bennu. The flyby, it seems, went perfectly. It brought the spacecraft within 11,000 miles of Antarctica and caused it to accelerate by an additional 8,500 miles per hour. Before departing for the distant asteroid of Bennu, the probe took some haunting images of Earth and Moon. On December 3, 2018, OSIRIS-Rex came within sight of its target. It marked the end of a 27-month chase that had taken the probe over 1 billion miles through space. Now NASA scientists would have to perform the tricky task of putting the probe into orbit around Bennu. To complete the move, the mission scientists first had to take detailed measurements of the rock's shape and mass. Maneuvering around a small body that basically has no gravity is very challenging. Heather Enos, deputy principal investigator for OSIRIS-Rex, explained to Space.com. So we do have to get a little more information to proceed every step of the way. NASA safely placed OSIRIS-Rex into orbit around the asteroid on the last day of 2018 and made 2 new world records. Firstly, Bennu broke the smallest space rock ever to be orbited by a spacecraft. Secondly, the probe broke the record for the nearest orbit of a body that small in space. At one point, the craft traveled just a single mile from its surface. Locked in orbit around Bennu, OSIRIS-Rex has since been conducting surveys of the asteroid's surface. Scouring its north and south poles, as well as its equator, the probe will generally complete flybys at a distance of around 4 miles. Scientists are now analyzing the data to make sure future decisions about the craft. Of course, the biggest decision concerns where exactly to land the probe. The sample site will in fact only be selected after 1.5 years of data gathering and analysis. Mission managers will present 2 potential landing sites in July of 2020. The final winner will be selected shortly thereafter, and OSIRIS-Rex will then set to work. However, the landing will be extremely brief. So brief, in fact, that OSIRIS-Rex scientists have compared it to a kiss, lasting just a couple seconds. That brief period should be enough, though, for the probe to acquire its sample. At least that's the idea behind its touch-and-go sample acquisition mechanism, TAGSAM. TAGSAM does the work of digging and collecting rock. It uses blasts of nitrogen gas to fracture the surface of the asteroid and release broken rock and dust, which is then collected inside a sample chamber. To allow for several attempts, the probe carries 3 gas-filled containers. For the mission to be a success, NASA must acquire a minimum of 2 ounces of asteroid material. However, to compensate for any measuring areas, they will attempt to gather around 5 ounces. TAGSAM, in fact, has the capacity to carry an additional 70 ounces should the mission demand it. In March of 2021, OSIRIS-Rex will commence its long journey home. The trip will take some 2.5 years to complete, and in September 2023, it will dispatch its cargo of asteroid rock. If all goes to plan, the sample should drop to Earth on a parachute in the deserts of Utah. Bennu is certainly capable of inflicting disaster on our planet, but thankfully it's unlikely to ever actually hit. According to NASA, there is a 1 in 2,700 chance that the asteroid will hit the Earth in the 22nd century's final quarter. For that to happen, though, the asteroid's present track would have to change during its 2,135th orbit. However, there's an important reason for NASA scientists to conduct a thorough risk assessment of the rock, and that's the Yarkovsky effect. The theory refers to the way an asteroid's path can be altered over time by the sun heating its surface. An unpredictable Yarkovsky effect could, technically, cause Bennu to redirect towards Earth. Likewise, the potential damage inflicted by Bennu in a hypothetical doomsday impact is a matter of dispute as well. While British tabloid The Sun has compared its potential impact to 80,000 Hiroshima atomic bombs, experts believe the destruction would likely be limited to a more localized area. An extinction event is therefore also unlikely. Nonetheless, the possibility of an asteroid colliding with the Earth at some point in the future is almost completely certain. Whether or not humans will be around to experience it, much less have the technology to avert it, is less certain. But there will always be a sensible, powerful, and scientific argument for studying space rock.